Since ancient times, the Huron River has acted as a vital transportation system and essential medium for industrial development. However, by the middle of the 20th century, the Huron River was terribly polluted from untreated discharges and accidental spills from industrial facilities. The Federal Clean Water Act, which was passed in 1972, set strict limits on discharges into our waterways from industrial facilities and wastewater treatment plants. These regulations led to great improvement in the water quality throughout the country, including the Huron River. Although the Huron River is now considered the cleanest urban river in southeast Michigan, our river still has pollution problems. Fortunately, the Washtenaw County Drain Commissioner works within the city and throughout the county to improve water quality.
Now what we're doing is try to deal with the remaining pollution, what's called non-point source pollution, the stormwater pollution, and that's harder to handle because it comes from so many different places. It comes from every one of us and every parcel of land. It's much harder to deal with a permit for such a diffused source of pollution.
There are two types of water systems that discharge into our waterways: wastewater and stormwater. The wastewater, which comes from all of the household and commercial buildings, is mechanically treated in the wastewater plant before being discharged into the river. On the other hand, the stormwater, which is mainly rainwater, runs overground or through a series of underground pipes directly into our creeks and rivers. This means that any pollutants left on the landscape or roadways may eventually end up in the river. The pollutants include oils, metals, phosphorus, sediments, and E. coli. E. coli are a type of bacteria commonly found in the intestines of warm-blooded animals. Water quality in rivers and lakes are generally measured by the amount of E. coli in the stream.
To look at the sources of E. coli bacteria, and those range from perhaps illegal connections to storm sewers where sanitary waste or other undesirable products might be somehow getting into our stormwater system, to urban wildlife. A big part of our problem around here are geese and raccoons.
Phosphorus is another pollutant that has great effect on water quality. It comes from the erosion of soils in construction sites, sanitary waste, pet waste, and from lawn fertilizers. The nutrient phosphorus is naturally abundant in southeast Michigan soils. Because our lawns don't need it, so much of the phosphorus in the fertilizers runs off into storm drains, which lead directly to our creeks and rivers. The extra phosphorus in the river causes algal blooms. Algal blooms can lead to a lack of oxygen in the water, which is an essential nutrient for aquatic plants and animals. Also, when these algae die, it produces strong odors when decaying. Algal blooms have had detrimental effects in several locations in the Huron River watershed, most notably at Ford and Belleville Lakes. So what can we do to stop these pollutants from flowing into the river system?
The strategy is slow the water down, hold it, and treat it on site. We want to contain the first flush, or about the first half inch of rain, which contains the most pollution that's being washed off the ground on the site, and let that get cleaned up by vegetation or mechanical means.
Until the 1950s, it was thought to be ideal if stormwater could run to the river as quickly as possible. But this was found to be a very bad strategy. The fast-running water would pick up a large amount of pollutants and carry all of them to the river. Ann Arbor's stormwater system is comprised of underground piping, 7 creeks, numerous small tributaries, and detention ponds. There are a number of small detention ponds on the south side of town that were originally constructed to prevent flooding in the Mallett's Creek system. Olson Park, on the north side of town, contains a large pond that is used for both recreation and as a detention pond in the Traver Creek system. These detention systems slow the water down and allow pollutants to settle out instead of being carried into the Huron River. Allen Creek is the city's most urban stream. It was channeled and piped in the 1920s to quickly carry water from downtown. Water flows rapidly through its 8 by 10 foot underground pipe, carrying pollutants from the urban area and dumping them directly into the Huron River. Also, Allen Creek is plagued by flooding problems because almost half the creek shed is covered in pavement and because there aren't any detention ponds to capture and slow the water as it heads to the river. Allen Creek flows through the middle of the city's business district, making it extremely hard to reconstruct this system. But the city is always looking for opportunities to improve the stormwater system.
Typically, we would put in bigger pipes that we can slow the water down and hold it back inside the pipe. We would put in what we would call swirl concentrators, which are devices that use physics to spin the water, and it causes the sediment to fall out into the bottom of the device and for the oils to come to the top. And we come back after storms and clean those out.
This is a parking lot at the former YMCA building site downtown. You'll see the magic of technology happen here.
This parking lot, when it rains on it, water goes through the pavement instead of running off into the stone below and into the sand below that. It doesn't generate runoff. And to demonstrate that, I'm going to pour this water onto the surface, and you'll see that it does not run off. And it's all soaked into the pavement.
Water on the surface will slowly drain into the groundwater system. This process screens a majority of pollutants and cleanses the water. These new technologies to hold and clean stormwater are becoming more common in new buildings. This Mallett's Creek Library building has a green roof with plants to drain water slowly. Excess water that filters through the roof then drains to the rain garden behind the building. What isn't used there slowly discharges to Mallett's Creek. This system is called a bioswale. Through this process, a large amount of rainwater is soaked into the ground in the surrounding area. The Washtenaw County Drain Commissioner recently partnered with the City of Ann Arbor and Pittsfield Township to complete a large stormwater detention system at Mary Beth Doyle Park. It was built not only to control floods, but also to reduce the amount of pollutants, especially phosphorus, in Mallett's Creek and the Huron River. The $3.4 million project was funded through grants and loans obtained by the Washtenaw County Drain Commissioner.
With the idea of redesigning the site, so not just the big flood events would be held back, and not just to protect from flood damage, but if it rained a half inch, that basin would capture quite a bit of that water. And while that water was standing there, slowly filtering out, the sediments would drop out, and the phosphorus would drop out, and we would be able to, at a later time, remove all that and clean up the water.
The water slows down as it flows into the pond in the northern part of the park so that contaminated sediments can settle to the bottom of the pond. The clean water in the upper part then flows into the large wetland area to the south. It is held there for several days to allow the wetland vegetation to filter the water naturally. During this process, a certain amount of the water is absorbed in the ground and sustains the wetland. This wetland preserve reduces 1/3 of the phosphorus input from Mallett's Creek to the Huron River. We depend on the Huron River for our drinking water, habitat for our fish and wildlife, and also for recreation. Keeping the Huron clean is all of our responsibility. The health of our river depends on it.